Okay, find the sum or difference. This is how you do this. Now, it's what you're doing yesterday. They're just not lined up quite as nicely. This is called P1. That's called a polynomial. And this is called P2. We are adding them together, but you don't just add everything. We got a 3 multiplied by x to the second power. Plus x, that would be a 1x. You will want to place 1s, trust me. And then a minus 4. Okay. And in the second polynomial, we have a 2 multiplied by an x to the second power, plus a 2 multiplied by x, then minus 3. Now, you need to make slots, okay? That would be your best bet not to get confused. The variable is x. What is the highest power that x is to? That's an x to the second. This would be an x to the first. Don't put a 1 though. That's a constant. There is no x. This is x to the second, and this is x to the first, and that's a constant. So I think the highest power that x ever is to is a second. So I make a slot for x to the second. Now, after that, I put plus, and I make a slot for just x. Okay, you won't see x to the first power. X means x to the first power, because that's why when I saw an x in past lessons, I put a 1. We're not going to be doing that. Then after the x slot comes a slot for non-x's. So it goes x to the second, x, constant. X to the second, then x, then constant. It's got to go in that order. So I look for x to the seconds. Here I have an x second multiplied by 3. Here I have an x second multiplied by 2. And what we do is add the 3 and the 2, and that would be 5. Okay? Remember, we're adding, so we keep the x at the second power. Now, cross those out after they've been added. Now you look for x. So I have an x here multiplied by a 1. Remember, x to the second power and x are two totally different things. Then I have an x here multiplied by a 2. So 1 plus 2 is 3. Now, this last space is for our constants. We have a negative 4 and a negative 3. So those will be added. Negative 7. There's the answer. Okay, now sometimes they're not x's, they're other variables. These are c's. So we have 8 multiplied by c to the second, minus 4 multiplied by c, plus 1 multiplied by nothing. That's why it's called a constant. Then we have negative 3 multiplied by c to the second, plus a 1 multiplied by c, plus 5 multiplied by nothing. So c is the variable. What's the highest power c is to? Well, that's c to the second. That'd be c to the first. Don't put a 1. So you got to recognize that if that's c, it's c to the first, c to the second, and c. So the highest exponent, the highest power c is to, is a c to the second. Then after that, we make a slot for c, because c to the second and c are totally different, plus a slot for my constants. So c to the second here multiplying by 8. C to the second here multiplied by negative 3. So we add those. We're allowed to add those two numbers because they're multiplied by the same variable with the same exponent. 5. Okay. Now c. Here's a c multiplied by a negative 4. And here's a c multiplied by a positive 1. So I add negative 4 and positive 1. That's negative 3. Then constants, that's stuff not 1's multiplied by nothing, 5's multiplied by nothing, so 1 plus 5 is 6. Okay. Next problem. Now, when you have a minus, we're doing what we did yesterday. We need to make that plus, and then everything in the parentheses after it needs to go opposite. So this 3m to the second goes to a negative 3. So now the m second has a negative 3. This m is multiplied by negative 2, but now it's multiplied by a positive 2. And this constant 5, it was positive. Now it's negative. So my variables, we have m to the second multiplied by 10, m multiplied by negative 7, then the constant 2. M to the second multiplied by negative 3, m multiplied by 2, and then a negative 5. So the highest I have is m to the second. That's the highest exponent. So I find my m to the seconds and add the multiplying numbers, 10 and negative 3. 10 plus negative 3 is 7. Now, after that, I put a slot for my m, then a slot for my constants. I should have done that right away. So m, I've got this m multiplied by negative 7, and I got this m multiplied by positive 2. So I can add now the negative 7 and the 2. So negative 7 plus 2 is negative 5. Then the constants, you have a positive 2 and a negative 5. So I can add those. 2 plus negative 5 is negative 3. It's just adding like terms together. Okay, next problem. We have 2 multiplied by x to the third minus 5 multiplied by x to the second plus a 1 multiplied by x. That's in the first polynomial. Then we have our plus. Then we have x to the 2 multiplied by x to the second plus 1 multiplied by x to the third and then minus 1. Now, look at your x is the variable. You have x to the third, x to the second, x to the first. Don't put a 1. X to the second, x to the third, and that's a constant. So the highest power we ever got to is x to the third. Now, then you make a slot for x to the second, because after the next number, power below a third power is a 2 power. Then a slot for x, that's like a 1 power, don't put a 1. And then the constant, okay? X third, x second, x constant. If I had x to the 6, I'd go x6, x fifth, x fourth, x third, x second, then x, then constant. So x third, right here, multiplied by a 2. And right there, multiplied by 1. You got to open your eyes and look, okay? See, there wouldn't be, this does not go with this. That's an x to the third, that's an x to the second. So it's 2 plus 1, that's 3. Now, let's look for x second. I have an x second here multiplied by a negative 5. And I have x second here multiplied by a 2. So now I'm allowed to add the negative 5 and the 2, which should be negative 3. Now, what do you have multiplied by just x? Well, we got a 1 multiplied by x here. I don't have anything here that's multiplied by x. So I just put 1 down. Then for constants, we just got this guy, negative 1, so we just put him in that slot. I don't add it to anything because it's the only one I have. Okay, in the next problem, we have 4 multiplied by n to the second plus 5. Then minus, if I come across a minus, I'm going to switch all these. So this n to the second multiplied by a negative 2, now it's multiplied by a positive 2. This n that's multiplied by a positive 2 is now multiplied by a negative 2. And this negative 4 that's multiplied by nothing, that's fine, but it has to now be a positive 4. Okay, so n to the second, n to the second, n to the first. So n to the second is the highest, okay? You don't add the 2's. You keep, when you're adding, you keep it at the same power. You don't change the power. It stays the same. Then, after n to the second comes n. That's the same thing as n to the first plus my constant. So n to the second, you got a 4 and you got a 2. So I take 4 plus 2, that would give me 6 multiplied by n to the second. Then n, I do not have anything multiplied by just n in the first polynomial. In the second one, we have this n multiplied by negative 2. Okay. Then the constants, okay? We have a 5 and a 4. 5 plus 4 is 9, okay? Okay, now in the next one, negative 4 multiplied by m to the second plus 3 multiplied by m minus 1. That's first polynomial, minus, okay, I don't like that. So plus, first I apply a 1 in front, so the m is multiplied by positive 1, but not anymore. Now it's multiplied by negative, and then that positive 2 is a negative. So for m's, I have m to the second, I have m, constant, and then m and a constant. So m to the second is the highest exponent. That's called the degree. After m to the second, I make a slot for m, then I make a constant slot. So I find where m to the second's at, there it is, multiplied by negative 4. I do not have m to the second here. So I just put negative 4. It's the only thing I have that multiplies m to the second. Then m, you have a positive 3 multiplying it there, and a negative 1 there. So I'm allowed to combine by adding the 3 and the negative 1, and that's 2. Now for constants, I have a negative 1 and a negative 2. So we add those, and that's negative 3. Okay, last one. We have 3 multiplied by m plus 4. Again, not a fan of, don't leave it minus. So now instead of a positive 2 times m to the second, it's a negative 2 times m to the second. The power does not change signs. Then instead of a negative 6 times m, it's a positive 6 times m. Then instead of a positive 5, we're going to have a negative 5. Okay? So when I look through the whole problem, not just the first parentheses, the whole problem, m to the second is my high. Okay? Then after m to the second, I make a slot for just m. Then I make a slot for constants. Okay, so m to the second, I have nothing there multiplied by m to the second. Here's m to the second, so it'd be negative 2. Then m, I have a 3 multiplied by m there and a 6 multiplied by m there. So 3 plus 6 is 9. So now I have 9 multiplied by m to the second. Then constants, I have a 4 and a negative 5. So I combine those, and that would be negative 1.